Okay, for these Z problems, which are probably the ones that you need the most analysis for, because there's multiple ways to do it. Like that video, the first thing you want to do is look at it, which is to make sure you know what you are given and being asked. Well, in this case, I'm trying to find I2. Where is I2? Here's I2. I want to find the current going through this branch on this side. And I want to find the voltage across this inductor. VL, L being inductance. It is also labeled. Since there's only one inductor, if you just said find VL, you want to be able to interpret that. But it is labeled, so we know we're going to find it across. I'm going to use the current divider rule. Before I even begin solving, I can tell that's what I'm going to do because I'm finding a current that I can look at. And if you want me to, happy to draw or label nodes. Let's do that. Get messy. What are you doing? Sorry. There's something going on with my, there. Why is it better? Okay. Sorry, it's a Surface Pro here. Okay, so here's a node, here's a node, here's a node. So I can tell by looking at this that the current is going to divide up in this node A into these two branches. So for me, I'm going to use the current divider rule because I want to know the current that has divided up. I total started it, and then it divided up in A, it rejoined in what we'll call B down here. Right, it divided in A, rejoined in B, so I want to find that current divider rule. CDR, I'm going to find I2, right? I total is what's being split up, and then the branch that I want, right, is I want my Z going through that side. So the first step, I'm writing the current divider rule, but it is always helpful to label these impedances, negative J10, J40. They're already in ohms, so I don't have to mess with the frequency equation. 2 pi FL, I just know 40 ohms, I write a J, negative J. And inside of orange is what I'm going to put here is everything between A and B, right? And so that is my Z equivalent. Everything in orange is my Z equivalent on my CDR equation. In case you forgot the CDR equation, it's I X equals I EQ, Z EQ over ZX, X being the branch, and ZEQ being everything between the node of dividing to the node of rejoining. So that Z equivalent is everything in orange, and the ZX that I'm looking for is everything in that branch from A to B. So in that case, and I'll write this one in blue because I have the blue arrow going down, it's 60 plus J40. That's the branch that I'm looking for. Well, the I total, I don't know yet, and the Z equivalent, I don't know yet. So let's solve for those. My Z total is what I'm going to use to get to my I total that's going to go into here. Z total is 20 plus, and I'll write this part in orange because it's everything in orange, 1 over negative J10 plus 1 over 60 plus J40. That's the equation. If you wanted to just write it, you could also write 20 plus negative J10 paralleled with 60 plus J40. If you wrote what I have in the top right, and then on the page you just wrote 1.33 minus J 10.67, I would call it good. You don't have to write the fraction formula if you don't want to. But the fraction formula, actually that's the part in orange. No. We'll write 20 ohms because this is 20 plus those is my Z total. That's 20 plus all that, Z total. So Z total comes out to 21.33 minus J 10.67. And this part in orange is that Z equivalent. So now over here to the right, I'll write V equals IZ, I equals V over Z. V is 120 angle 0. We're looking for all the totals because I'm solving for I total, right? I total, V total, Z total. Z total 21.6, 21.33 minus J 10.67. I total comes out to 5.04 angle 26.57 degrees, and that's in amps. So now everything gets plugged in. 5.04 angle 26.57. Z equivalent 1.33 minus J 10.67, because that's that Z equivalent. It doesn't include the 20 ohm resistor because the current already went through the 20 ohm resistor before it divided up in node A. So it's the 1.33, not the 21. It doesn't include the 20. And then down below, I'm looking for everything in that branch. We already wrote it, but as a reminder, it's put everything in the branch between A to B. So it's not just a 60 ohm resistor, it's 60 plus J40. I plug all of that in and I get I2, which is 751 milliamps, angle negative 90. There's I2. I'll write in green part B, right, which is VL. Well, VL is equal to the current going through the inductor times the Z of the inductor. And these have all been vectors in case that wasn't clear with all my angles. These are all vectors. Which is everything in AC. Everything in AC is pretty much vector math. But as a reminder, these were all vectors. So the voltage going through across the inductor, the voltage across the inductor is the current going through the inductor. Well, that is what we just saw for, 751 milliamps, angle negative 90. The Z of the inductor is just J40. Another way to write that would be 40 angle positive 90. The voltage across this particular inductor comes out to 30 angle 0 volts.